Hi folks, welcome back. Section 5.1, Differential Equation Introduction. This is WebAssign number 12. I promised I would do an example for you and show you a kind of a video solution step by step, and here's that example. First thing I want to look at is that, well, we have a differential equation, dy dx equals x times the quantity x minus 2. And I know that we have a four-step process for solving differential equations. We do this. We start by writing the differential equation, separating variables, integrating, and then rewriting it as y equals f of x. A lot of this is almost already done for us. In terms of writing it, yeah, it's already written there for us. We don't have to do anything else there. But I do want to make one quick comment. This thing has an issue. There's a square root symbol there, and I remember from way back in maybe an algebra class or something like that, some teacher said you're not allowed to put negative signs under the square root symbol, right? At least not in real numbers, and this is calculus of real numbers. So let's just comment on this. We have x minus 12 under the square root symbol. That's got to be greater than or equal to 0, which that means that for this differential equation, x has to be greater than or equal to 12. And that is a domain restriction for this Diffie. Okay, I'm making note of that now because I'm encouraging you to do that early in your process. When you get to the end and you're writing out your solution, your differential equation, if you don't go back and check this domain restriction, you could be in trouble. So it's a good idea to always look at, are there any domain restrictions in your differential equation? Because they may or may not be the same as any domain restrictions in your final solution, and you've got to make sure you include this domain restriction at the end. Okay, so separate variables now. It's time to do that. We separate, it looks like this. So I'm done with that. The integration step, well, I'm going to go ahead and take the antiderivative of the left and the right-hand side, and that's where things are going to slow down a little bit. Left-hand side is pretty straightforward, but the right-hand side is going to need a little work. This is a product, and we don't have a product rule for antiderivatives, so I'm going to need to maybe look at U substitution. And the first place I would look, I'd look under the square root symbol there. I would probably let U equal x minus 12 and see if that gets us anywhere. Take the derivative of both sides, we get du equals dx. And then let's see where we're at. So we have u substitution to take care of this for us, where it's going to be the square root of u. We have du equals dx, so we're good there. But we do have a problem here. We don't have, right now, we don't currently have an expression in u that will replace x. So let's go over here and see what we can do. If we add 12 to both sides, that equals x. Oh, there, that's beautiful. That's now our substitution for x to make sure we take care of that. So this then becomes the antiderivative of u plus 12 times the square root of u dx. Still can't antidifferentiate in this form because it's a product. We need to expand this. Let's expand. U times u to the 1/2 is u to the 3/2. 12 times u to the 1/2 is 12u to the 1/2. And we're doing this all with respect to x. Great. We turned a product into a sum. Now we can use our power rule for antiderivatives, which will look like this. Don't forget your constant of integration there at the end. Let's go ahead and clean this up a little bit. Substituting back my expression for x in terms of u. 12 times 2/3, let's see, 12 times 2 is 24. 24 divided by 3 is 8. And we're done. Now you could enter this in WebAssign and you would get full credit, but I want to caution you, please add this little thing at the end. And you don't need this in WebAssign, but you will need to think about this going forward. And I know it seems obvious. You're looking at this equation right here, this function, and you're like, well, Mr. S, why do I need to bother putting that domain restriction in there? I have I have roots here. I have even numbered roots, so I know that the expression inside there has to be greater than or equal to 0. Isn't that taken care of? Isn't that part of the implied domain? And I would say, yes, it is for this example. But there are other differential equations we'll solve where if you don't take this domain restriction from the original differential equation into consideration, your final answer will be wrong. Good rule of thumb, always state a domain for your solution to your differential equation. That's it, folks. Last thing I'll mention here is if you looked in WebAssign at the practice another version, you would see a very different looking answer. And I'll just share with you what they did to get that different looking answer. What they did is they factored out, oh, he's writing with the highlighter. That's never very effective. So what they did in WebAssign was they factored out an x to the 3/2. Excuse me, x minus 12 to the 3/2. And that would leave here a 2/5 times x minus 12 plus 8 times, well, x minus 12 to the 3/2 was already factored out, so there's nothing else there. I got to put, boom. Oh, don't forget plus 8. And then if we went ahead and rewrote this, we could distribute out that 2/5. That would be 2/5 x minus 24/5 plus 8, which is also known as 40/5. Cleaning this up, we might write it like this: x minus 12 to the 3/2 times 2/5 x plus 16/5, all plus some constant for x greater than or equal to 12. And again, folks, this process here of factoring out a GCF and then rewriting, it's not necessary. But if you're looking in WebAssign at the practice another version, you might see that they did that. Okay, folks, if you have any questions, please do not hesitate to hit the Ask Your Teacher button.